Hey guys. Okay, so we're going to be starting the first set of notes for chapter 2. And we're going to start by figuring out if something is a function or not. How do we tell? Okay, so one thing you want to look at is no cheating x's, which means your x's cannot repeat. You also need to pass the vertical line test. So I put this line right here in case you forget what vertical looks like. So that's vertical, has to pass the vertical line test. And I'll explain what that means here more in a little bit. Okay, so if I look at this first set, this is what you call a mapping diagram. Your x's come first and then your y's. So these a's represent my x's. The b represent my y's. Okay, we know x's cannot repeat, so I want to be looking at these. Notice off of each x, there's only one arrow. So there's one arrow coming off of this positive one coming off a negative one, and so on all the way down. All right, so I know there's only one number attached to each of my x's, so that's why this one is a function. None of these x's are cheating. None of them are repeating. All right, same thing on the other one. The first represent my x's, so the a's are my x's. The b's represent my y's. We want to pay attention to the x's. Okay, on this one, notice that there are two arrows coming off of one. So one is a cheater because one is with this negative one is also with this positive one. So because there's two arrows coming off, I know that this x is a cheater. We have a cheating x's, that's why no, it is not a function. Okay, what if we're given a graph? Okay, so we have to perform the vertical line test. So on this one, no matter where I draw my vertical line, I see that it touches my graph only once. If it touches only once, it's good to go. It's a function. But if you look on the second one, if there's anywhere you could draw a vertical line and it will touch your graph twice in two spots, it's not a function. So only once is okay. But if it goes through and that same line will touch the graph twice, so here and here, it's not a function. All right, finally, what if we're given a table? Okay, so remember we look at the x's, no cheating x's, no repeating x's. So as you see, each of these numbers are different. So that this one is a function, no repeating x's, no cheating x's. All right, on this next one, notice we have a 1 here and a 1 here. 1 goes with 2, 1 also goes with 5. So that is a cheater, cheating x's, they repeat, not a function. All right, so now we're going to go through some examples. We're going to determine whether it is a function or if it's not a function. Okay, so since A is a graph, we're going to use the vertical line test. Remember, vertical looks like this, up and down. Okay, so we're going to see if there's anywhere that I can draw a vertical line that will go through more than one point. So let me highlight my points real quick so we can see them better. Boom, 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 boom. Okay, so there's all my points. Okay, if there is anywhere on this graph that I could draw a vertical line and it will touch more than one, it's not a function. So watch this. Look at this vertical line. Uh-oh, it touched once, twice. That's not okay. So this is not a function. Okay, so on B, this is a mapping diagram. So remember, we look at our x's. If you look at each of your x's, we notice there's only one arrow coming off of the -7, one arrow coming off of the -2, one arrow coming off of 0, and one arrow coming off of 5. So make sure you're looking at the x's. Those are all good. None of them have two arrows coming off. So this one is a function. All right, so we have a graph again, which means we need to use the vertical line test, the up and down. So is there anywhere on this graph from here to here that I could draw a vertical line that will touch it more than once? So let's try a few. Usually you can see it right away. There, that line only touches the graph there. That's once. That's okay. That vertical line only touches that parabola once right here. That's okay. That vertical line touches once here. So no matter where I would draw my vertical line, I would only touch that parabola one space at a time. So once, once, once. So that one is okay. That's a function. All right, so on our table, we know that we look at our x's. We don't want any cheating x's, which means x's cannot repeat. So I'm looking at these numbers only. -2, 0, 4, 8. Okay, the y's are repeating, but we don't care about the y's. We are looking at the x's, no cheating x's. And because each of these x values are different, it's not cheating, that is a function. All right, so we're back to a mapping diagram. Remember, x's are first, then the y's. We need to pay attention to our x's. And remember, when you're looking at a mapping diagram, you want only one arrow coming off of each one of your x values. Well, there's one arrow coming off of 1, so that's good. One arrow coming off of 2, one arrow coming off of 3. But there are 2 arrows coming off of this 0. So that's why it is not okay. That is not a function. Oops, my N, okay. All right, so now we have another table. Now the first one is my x's, second one is my y. We want to pay attention to the x's. Remember, we're looking for no cheating x's, no repeating x's. 3, 4, 5, 4, 10. Uh-oh. I see a 4 here. I see a 4 here. So 4 is with 7. 4 is also with 14. That's not okay. That's a cheater, not a function. All right, so let's recap. If you have a graph of some type on A and C, if you have a graph, you perform the vertical line test. If you have a vertical line test that will go through 2 points on the graph, that's not okay, not a function. If every time you draw a vertical line, it only touches your graph once, that is okay, it is a function. Okay, mapping diagrams, like on B and E. On mapping diagrams, you always look at your x's and you make sure there's only one arrow off of each x value. That makes it a function. So if you happen to have 2 arrows coming off of your x value, it's not a function. And then table, you look at your x values. Make sure you look for cheating, repeating x's. If they're all different, it's a function. But if you have a number that repeats, like here, 4 and 4, not a function. Okay, so that's how you tell whether it is a function or if it's not a function. Okay, so now we're going to go into evaluating functions. And I'm going to show you 2 different ways. So one second, real quick. I'm going to start pulling up my calculator so it's ready in just a second, because I'm going to show you a trick. All right, first I'm going to teach you how to do this by hand. After I teach you how to do it by hand, then I'm going to show you the calculator trick. Okay, so this is what function notation looks like. This guy right here, this whole f of x, that's just a fancy way of writing y. So really all this means is y equals 3x plus 1. Okay, so students ask me, why do they write it like this then? Okay, because there's a lot of times that you will have more than one equation, and this will help you differentiate between 2 different equations. So you could have one equation called f of x, and then you could have another equation called g of x or h of x, and it just helps you. This is graph F, this is graph G. You can determine which one's which easily. Okay, so remember, all it is it means y equals, but we have that extra little letter out there to help us determine which graph we're talking about. All right, so really remember this whole thing just means y equals 2 over 5x plus 5. Okay, notice on the inside of that parenthesis is an x. And it's telling me to find g of 25. So that number inside the parenthesis is an x value. So really what this is saying the whole thing means y. So this is just a really short way of writing what is the y value when x is 25. So one more time, this whole thing means y. So this little piece right here is just a short way of saying what is the y value when x is 25. So what I'm going to do is I'm going to take this 25 and I'm going to plug it in for x. All right, so g of 25 will equal 2 over 5 when you plug in, you use parentheses. So instead of this x, I'm going to put a parentheses and I'm going to plug that 25 in. Close parentheses. So I have 2 over 5. I plugged in 25 for x. Now I'm going to write plus 5. So g of 25 is equal to, now we're going to go type this piece into the calculator. All right, so I'm going to add a calculator, and it's a fraction, so control divide. I have a 2 on top, a 5 on bottom, get out from underneath. We open our parentheses, 25, close your parentheses, plus 5. So I know that's equal to 15. Uh-oh. Sorry guys, gotta scan my QR code again. Oh, there it goes. Never mind, I lied. All right, so the calculator told us that was 15. So really, when you're evaluating a function, I know this value is my x, so I had to plug it in for x, and then I calculated. 2 over 5 times 25 plus 5 gave me the 15. So remember, this means y equals 15 when x is 25. All right, now I'm going to show you how to do that using the calculator, okay? I'm going to show you how to do it using the graph. Leave that over there for now. Okay, so if you're going to graph, always go to the home screen, always click a new document, never save. Okay, we're going to go to a graph. Okay, if you're going to use the graph to evaluate it, you're going to graph this guy right here. Notice that says f of x equals, same thing as g of x. So all I'm going to type in is this 2 over 5x plus 5. So I'm typing in exactly the equation that it gave me. Notice, I'm typing in 2 over 5x plus 5. That's the equation it gave me. Click enter. All right, so there's the graph of that equation. All right, so now I need to find when x is 25. So to do that, I'm going to use trace. So I'm going to go to menu, trace, graph trace. Okay, so you see how this little x looking thing pops up. So when you're in trace, you can jump to any x value you want. So as long as you see this little x value, this little x thing right here, trace, I can type in an x value, press enter, and it will jump me there. Okay, so remember the x we want to go to is when x is 25. So I'm going to type 2, 5. This pops up, x equals 2, 5. All right, enter. It'll jump me to where x is 25, and this is my y value. Notice it's exactly the same. So when x was 25, y is 15. That's the exact same answer we got when we plugged it in ourselves. All right, so we're going to try it again. We're going to do it by hand first. After we do it by hand, then we're going to use our calculator to check ourselves. All right, so remember, inside the parentheses is our x. So this is just saying the whole thing is y equals x squared minus 5. Well, I want to find h of negative 4. Well, remember, that's your x value. So I'm going to take this value and plug it in for x. Remember, when you plug in for x, you have to use parentheses. So I'm going to put a parentheses. Equals. Okay, so parentheses, I'm going to put negative 4, close parentheses, square. So remember, this x I'm replacing with negative 4 in parentheses, then I square it. Notice that square is on the outside of the parentheses. So I plugged in negative 4 for this, then I squared it, minus 5. All right, so now I just have to type that part of my calculator to figure out what is h of negative 4 equal to. All right, so let's go to the calculator. And I'm going to type in this guy right here exactly as I see it. So parentheses, negative 4, close parentheses, then I square it. This button right here will square it. Then I'm going to press minus 5. All right, so that's 11. So I know h of negative 4 is 11. So remember, this is how you read it. Y equals 11 when x was negative 4. All right, let's try it on the calculator now by graphing. So I'm going to go to the home screen. New document always, never save, go to graph. Okay, so this time, remember, you type in exactly the equation it gave you. So I'm going to type in this x squared minus 5. X squared minus 5. All right, so now we're going to use trace to jump to where x is negative 4. So remember, to get to trace, we press menu, trace, graph trace. Notice it looks like an x, so as soon as I see that, I can type in any x value. And our x value is negative 4, so I'm going to type in negative 4 and click enter. Notice, when x is negative 4, y is 11, exactly the same as what we got. All right, so I'm going to continue to do it both ways for now. Just to get us in the practice of it. Okay, on C, h of x is equal to 3x squared. I want to find h of 5. Okay, so remember this whole thing means y, and it's asking me to find y when x is 5. So notice x is on the inside of the parentheses. So that 5 is on the inside of the parentheses, which means when x is 5. All right, so first let's do it by hand. I know h of 5 is equal to 3. Instead of x, we put parentheses and plug in, so parentheses 5. So 3, I plugged in for x. Now I have to square it. Remember, that square is on the outside. All right, so now all I have to do is type this piece into my calculator to figure out what is h of 5 equal to. Always a new document, never save, add a calculator. So it's 3, parentheses, 5, close parentheses, square it. So I know that's 75. So remember, the way we read this is y equals 75 when x was 5. All right, let's check ourselves using graphing. So I'm going to press the home screen, new document, not save, and add a graph. Okay, so remember, when you do it by graphing, you're going to graph the equation exactly as it gave you. So 3x squared. Enter. Okay, well, I want when x is 5, so we use trace to do that. Menu, trace, graph trace. Oops. All right, notice it looks like an x, so I can type in my x value. My x value is 5, so I type in 5, Click enter. So I can see right here that when x is 5, y is 75. That matches what we got exactly. So you can use this as your main way of doing it, or you can use this way as a way to check if you did it correctly. All right, so let's keep doing it by hand, and then we'll check using the graph. Okay, so g of x, which aka y pretty much, equals 2 to the x power plus 4. It wants me to find g of 3. So remember, this 3 represents the x value. All right, so let's plug in. G of 3 equals 2. All right, and this is a little exponent. That's a little guy up in the air, right? So I need to put a 3 up there, and then plus 4. All right, so to figure out what g of 3 is, now all I have to do is go type this into the calculator. So 2, and how do you type in an exponent? Okay, well you see this little caret key, this little arrow up, if you click that guy, boom, there it goes. Now I'm going to type a 3 in there. Okay, but you see how your cursor is up in the air? So you need to press the over button so it's no longer an exponent. Then plus 4. So 2 to the third power plus 4 equals 12. So one more time, we read this as y equals 12 when x is 3. All right, so let's check ourselves using graph. Okay, so remember, when you're going to graph, you have to type in the equation exactly as it gave you. So 2 to the x power plus 4. So 2, press the up caret key to get our exponent of x. Press the right arrow to get out of the exponent, plus 4. So that says 2 to the x power plus 4. All right, so now I need to jump to where x is 3. So I use trace, menu, 5, 1. Notice it looks like an x, so I can type in my x value of 3. So push 3, enter. I know x is 3 and y is 12. Exactly what we got. Okay, one thing I do want to show you real quick, or want you to put on your notes, is the steps on how to use trace so you don't forget, or if you do forget, you can come back and look. So how to use trace, remember it's menu, 5, 1. Menu 5, 1, that's how you get to trace. Okay, so that's how we evaluated functions when we were actually given the equation. But what happens if you're given a graph? Uh-oh. Where'd it go? Okay, so what happens if you're given a graph, not an equation? So you can't plug in for x, okay? So we know our x axis is right here. All right? This is our y-axis. It tells me to evaluate f of 2. So remember, this whole thing means what is y when x is 2. So that's an x value. Okay, so we're going to go to where x is 2. So here's 0, 1, 2. X is 2 right here. Okay, then what we're going to do is we're going to trace until we get to our graph. So x is 2 right here, but our graph is up here. So that's 1, 1, 2, 3, 4. So when the x value is 2, our graph is at a height of 4. That's the y value. All right, let's try this one. It says evaluate f of 5. Remember, this is asking what is the y value when the x is 5. So let's go to where x is 5. 1, 2, 3, 4, 5. You got to go to your graph, which is here. Trace it over to your y. So when x is 5, my graph is at a height of 1. Okay, this one's a little bit different. This one says, what values of x? So now instead of trying to find y given x, now I'm trying to find x given y. This whole thing means y. Oops. Okay, so this says y equals 1. So you might want to rewrite that out to the side. So we know that y equals 1. I'm going to pick a different color. And I'm going to go highlight where y is 1. Okay, remember, y axis is right here, so y is 1 is right here at the height of 1. So that's where y is 1, and I want to figure out what are each of those x values. So notice my graph is at a height of 1 here, here, and here. So we have to find each of those x values. So trace them to the x-axis. So drop this down. That's at, start at 0, back 1, 2, 3. So that's negative 3. Here's our other one. Trace that down. That's the x. This is the origin. That's over 1, so that's a positive 1. Here's our last one. Trace it to the x-axis. That's at positive 5. So one of the main things you need to remember is how to read these guys. The number on the inside, that's your x value. The whole thing means y. So I knew that y was equal to 1. So I go to a height of 1 because y is up and down. So I went to a height of 1. And I know my graph was at a height of 1 in 3 different spaces. So then what I did is I traced it down to the x-axis to figure out what was x when it was at a height of 1. Well, I'm at a height of 1 here, x was negative 3. I'm at a height of 1 here, x was at 1. I'm at a height of 1 here, x was at 5. All right, let's try this again. Okay, so remember the number inside of your parentheses is your x. So I know what x is 5. So these are your x-axis down here. This is x, so I'm going to go where x is 5. And I see my graph is already exactly right there. Boom. So now what I need to do is figure out what is the y value. Well, these are the y numbers. So when x is at 5, the y value is, trace it over to the y, 0. So the way you read this is y is 0 when x is 5. Now I want x to be 2.5, so 2.5. So let's go to 2.5, which is, here's 2, here's 3, so this is 2.5. Let's go find our graph. So this is 2.5. My graph is all the way up here. So x is 2.5. My graph is at this height. Well, let's trace it over to the y-axis. So when my x is at 2.5, my graph is at a height of 100. So we read that y equals 100 when x is 2.5. Okay, C looks a little different. Now it's asking what values of x. So now I'm finding x when y equals 60. So let's rewrite that. I know that this guy means y equals 60. So these are your y's. So go to where y is 60. Some of these numbers are a little hard to read, but 0, 10, 20, 30, 40, 50, 60. This guy is 60. And I'm going to highlight at 60. Because I want to figure out where my graph is at when it's at a height of 60. So I know it's here. Keep going. It's also at a height of 60 here. So now I need to trace those to the x-axis because that's what I'm trying to find. So when it's at a height of 60, the x value is 1. It's also at a height of 60 here, and the x value is 4. So when x is 1, it's at a height of 60. Also, when x is 4, it's at a height of 60. Your graph doesn't have it labeled, so go ahead and put x down here. We know that our x's are these numbers, our y's are these numbers. Okay, for this next question. Students freak out on it, but it's not really that bad as long as you understand how to read function notation. So, for a function y equals g of x, we know that this was just a special way of writing y. So it is known that g of negative 2 equals 7. Well, remember, the number on the inside of the parentheses is x. So if I look here, I know the number in front of the parentheses, inside the parentheses is negative 2, so that means that's my x value. Okay, let's talk real quick, guys. When you write a point, it's always x, comma, y. So we know that inside the parentheses, that's your x value. So I know my x value is negative 2. Okay, we know that this whole thing means y. So this whole thing is y. So what that's saying is y is equal to 7 when x is negative 2. So y equals 7 when x is negative 2. So that y value is 7. So x is negative 2. The whole thing y is 7. X comma y. So that answer is C. All right, later guys.